Hey guys, so in today's video I'm going to be going over Anki and we're just going to be reviewing one last day of Pandas data in essence, pretty much just going over the vocab, seeing what returns errors, what doesn't, and then I'm going to go ahead and perform some of these, or at least try to recall them in memory, and then go over them in like a collab notebook over here. So the data that I'm going to be working with is the Olympic summer data set as well as the Titanic data set. Both are from Kaggle. You can just Google it and then you should be able to find it. Olympic summer is the one that this one is. You'll also notice that there's a winter, but this will be, I'm working with summer. Now, one of the things that I did want to kind of mention also is that when it comes to these flashcards, the point of them is to kind of use them again and again and again. And since this is my 5th day of using them, I've really come to really grasp the vocabulary, and I haven't really done any practice outside of creating these videos as I go through them on the video itself. Like I haven't gone on my own and just said flip through the flashcard, flip, flip, flip. And in turn, I've realized that over the last 5 days, like everything is just internalized much more. I know it a lot better, and I would feel very confident, at least in my skills and abilities, to, for the most part, working with Pandas. The only thing that I would like to go over is rolling windows functions. That one I'm still a little weak on, but otherwise I'll just go ahead and dive in. And then in case you're curious, the reason I mentioned rolling windows functions, I'm probably butchering that, but in essence, I was asked one of those questions on a interview, and I butchered it. So that wasn't very fun. But left joins, group bys, and all the rest, manipulating data, seeing how we could get rid of null or nan values, pd.dummy, to numeric, and all the other stuff I'm able to kind of comprehend and able to understand. Next week I'll go ahead and go over these, like actually write them out. So let's just dive right in after this 1 minute intro, or 3 minute. So with regards to this question, what does the following output? Feel free to pause the video if you'd like to answer the question, like as I go through them. Just know some of these will be answers, so try to work backwards from the answer. Yeah, just try to work backwards. So with regards to this question, what will the following output return? So if we're working with this Titanic data set, and if these are our columns, if our goal, would we be able to, for example, do Titanic.columns, select the 0, the first column itself, which would be survived, would we be able to rename it to alive? Well, if you're kind of curious, no, we wouldn't be able to. What would happen is it'd return an error. So if we wanted to go ahead and rename Titanic, what we would do, or like the columns, what we could do is we could do pd.columns equals list of new column names. So this one would be alive, and then we could go ahead and like capitalize all of the other columns. We'd want to make sure though that we do them in the proper order. Since we start with survived, then we move on to P class, and then we move on to sex, age, sips, parch, and so on. But that'd be one way of renaming the column names. Another way of being able to rename the column names would be pd.rename, or sorry, dataframe.rename, and then go ahead and set that equal to the new column name. So what we could do is we could go ahead and do like survived, which would be the old name, and then we go ahead and rename that to alive. And then from there, I believe we do access equals 1, aka or columns. Or is it column or column? I forget. If there's an error, it'd probably be columns, plural. And then we do inplace equals true. So if we were to go ahead and see what the answer is, we get the result. So as I said earlier, we'd return an error. In essence, index does not support mutable operations. So pretty much we just wouldn't be able to select survived column and then rename it to alive. But if you did want to rename the columns, one way of doing it would be titanic.columns equals a new list, and then just rename all the columns in order. Just know if you would have put sex right here, it would have been sex, and this could have been class, so just be aware of what order you place them in. And then next, so this is just a different data frame, but they had pictures, so I can add them to the flashcard. So one way of being able to do it would be dataframe.rename, Oh, I screwed that up. So it would actually be columns. Actually, I think that both would work. So columns, column name, new column name, axis equals 1, and in place equals true. So since I have collab up, I'm just going to go ahead and check out this one without using columns equals. So let's go ahead and do that right now. So if we wanted to, it would be dataframe.rename survived would now be alive, and then axis equals 1, and then in place equals true. So if we were to run that and then do df.head, nope, that was wrong. So then would it be columns? Or actually what I did last time is I did columns. So it'd be column, check it, nope. Try one more time, columns, run it. And no, again, it would not. So we would then need to go ahead and call the term columns equals this. And then from there, we would just do axis equals 1 because 1 is the column itself. Did I misspell it? Column. Nope. So what was it? How was this written? Dataframe.rename columns equals old name, new name. And then to make this easy, let's go ahead and copy it over. Actually, I should do this. So dataframe.rename, and then we have column, right? Columns equals survived, old column name, new column name, axis equals 1, in place equals true. Now rename got an expected keyword, column. So maybe this doesn't work. These are spelled correctly, dataframe.rename, columns equals a new dictionary. Interesting. So let's go ahead and search it, and let's just kind of see what the first answer might be. So one of the answers would be group by, rename columns equals a mean, and that'd just be for group by. And they would have their own. So am I screwing this up then? How am I screwing this up? So it'd be dataframe.rename columns equals survived, alive, comma, axis equals 1. Let's go ahead and comment this out then. Let's go ahead and bring this one back. And let's go ahead and select our data frame columns, which again, it still should be survived, and then this one would go ahead and be alive. Nice. So cannot specify both axis and any index or columns. So this is fun. At least in essence, we're able to learn about it though. So way of changing a specific column name. From there we could do to list, so you'd be index names.index.to. df equals df.rename. How odd. Right? Now, if you're kind of like me where you just kind of skim through everything because you really just want to have the answer, interesting. Let's go ahead and do it one more time, survived. And then we'll go ahead and do alive. Let's go ahead and get rid of this. Since we're saving that, and let's go ahead and do data frame. So what can we take away from this? So the way it's written is the same in essence, but perhaps then we shouldn't be using axis equals 1. We can still use in place. So if we wanted to, we could do like in place equals true. In place equals true. But then we can go ahead and get rid of this variable and rerun it. Well, I mean, it would still be there. So let's actually go ahead and rename it to, how about we rename body to, bod, no, how about, okay, bod. So what would be the output? So body was renamed to bod. So then the only reason that we weren't able to rename it then would be because of axis equals 1. So what would axis be? What's the traditional at least? So rename. Axis is optional. Okay, so that's good to know then. And then it would be columns, not column. Okay, so I will go ahead and update this flashcard so that we can get rid of axis equals 1, and then the rest should work properly. So let's go ahead and remove that. Now we also still have inplace, which is equal to true, and then we also have dataframe.rename, and then columns equals string.upper. And then let's go ahead and just run that one more time. So let's go ahead and do rename str.upper. And then inplace equals true. And how did I misspell it? Columns equals that. Columns equals string.upper. Now we'd be able to see all these are uppercase. Okay, perfect. So would I need to still remove it? Nope. And then here would be some additional useful pieces of information. Feel free to copy these down if you want to. So dataframe.rename, columns equals lambda of x, and then we're just going to go ahead and take the first position onward, and in essence getting rid of position 0. And then likewise also set axis, and then that would go ahead and rename these as well. So even though we screwed up on the rename, I'm going to go ahead and click easy, and I'll study that in like 9 days time. Just as a good refresh. So the next question is, this returns all rows of men over the age of 14. Selects data based on and condition statements. So if we had to, how could we identify all men over the age of 14? Men, aka males. So if we had to do that, how could we do this over here? So if I had to, what I would do is I'd go ahead and do dataframe.head just to kind of gain an understanding of what we're working with. So we have male, female. So if we wanted to get them over the age of 14, something that we could do is we could do, if I'm not mistaken, dataframe.age greater than 14 and dataframe, I feel like these should be wrapped as tuples, but I'll go ahead and see in a second. Dataframe dot, what was it, sex? Actually, I got to make these all capital too, because we capitalized them. So age and sex. Sex equals to male. And let's go ahead and just say df male. Yeah, we'll just do male for now. And then from there we go df male. Types for an list, right? So what I believe it needs to be done is it needs to be wrapped. Nope. It needs to be wrapped somehow. Identify. What was it? Identify. I'm blanking. What is it? Why am I blanking? Identify two conditions. Pandas. And let's go ahead and do multiple conditions while indexing. So that'll be our data frame, df1 equals data frame, tuple, and tuple. So our answer should then be updated to go ahead and be like this. So let's get rid of that. And rather than doing these, it would be wrapped like that. Get rid of these. And then go ahead and get rid of this one as well. And then run it. So then that would go ahead and return all men above the age of 14. Now the flashcard will probably be a little different. Actually, it'll be very different. But just know that this is also one of the ways. So what I'm going to go ahead and do is I'll go ahead and save this as well. So let's go ahead and see what the answer was. So what does the below output? So we have a variable mask. So titanic.sex equals the male. So then this is the head, so it'll be true or false whether it is a male or not. And then likewise, it'll go ahead and return mask 2, which is if it's greater than 14. And then in order to run the code, what we could do is we do titanic.locate mask, and I feel like this symbol is not correct, but I'll go ahead and leave it for now. Let's edit this though. And let's go ahead and just add another option. So we'll do option 1, and then let's go ahead and turn this into a different color. Let's make it black. So this would be one option. And then if I can, let's go ahead and take a screenshot as well. Now let's go ahead and drag and drop. So now we have it here. And this is just kind of a preview of how I create my own flashcards. It's actually really useful, especially with Mac. So you just do Command-Shift-4 and then drag and drop. And then Windows, it's Windows key and then print, right? I'm looking at my other computer right now, looking at it. But yeah, what I think I'll do is I'll go ahead and leave this alone for now. I'll come back to this on my own time and then update it and just double check it. But just know if you did need to find individuals that are male and older than the age of 14, something you could do is just wrap them all into one statement, and then make sure you remember that these are going to be, in essence, a tuple, just for simplicity, because we know that tuples are the brackets, not brackets, the brackets. Sure. So let's go ahead and close this out. Show the answer. Good. Oh no, I didn't save it. Oh, come on. Fail. That's horrid. Oh no, I did. I don't get. Okay, I'm just gonna move on. So we have that. This. Boom. Option 1. All right, perfect. I will select easy, and then we'll just come back to that another time. So what does the following output? So we have our summer data set, and now what we're going to do is we're going to do summer.rename, gender, sex, city, host, and then access equals column, and then inplace equals true. So since we have our summer data set, and since we don't really need to worry about it, and after everything we actually just went through, I'm going to go ahead and copy this, and I'm going to go ahead and test the code to see if it's still running properly. Now just know that if you remember when I pasted my code from Colab into here, how it had like that special color, and then I adjusted the color. I do the same thing with other Colab, like other data sets or other notebooks, and whenever I just want to copy and paste the code, I'll just go ahead and do that, and that's why some of these will be in orange and blue versus all just black, right? So in essence, the point that I'm making is I've copied this code over, so then I could just remember it. Someone else has already written it. I'm just going to go ahead and memorize what the actual function is and then how it's used by taking the screenshot. So let's go ahead and run this code and see if it operates with our summer data set. So summer is already loaded and we already have it run. Now let's actually go ahead and see what the head would be. So summer.head 1. And then we see we have year, city, sport, discipline. So the thing that we're going to rename is gender, which is right here. And then we're also going to rename city. So city, we want to rename it to host city. Gender, we want it to rename to sex. So access equals column and inplace equals true. Oh, come on. Summer.head. And then we'll go ahead and look at the head. Now we see that there's the difference. So that actually bugs me quite a bit then as to why I didn't update it last time. But trust the code, generally speaking. But always make sure that you run it, and then if you do come into any situation, just go ahead and obviously do what I did, just search for an answer online. But as we see, what happened was it went ahead and updated the specific column that we wanted to update. So we were going to go ahead and show the answer. We'd see that it renames the columns. Gender becomes sex, city become host city. And then, so this one's a little different because athlete, this column is on the index, whereas athlete is like right here for us. So we haven't really updated the index. But since we're working on stuff and since it's just good for practice, how would you update? So just go ahead and update athlete to be the index. Feel free to pause the video and then try to figure out how you would update the athlete to now become the index. So if you have already figured out, great. Otherwise, I'm going to go ahead and run it right now, like how we would go ahead and set the index. So what we would do is we do summer.setIndex. And then from there, we'd go ahead and choose athlete. Now we'd go ahead and make sure that drop equals true. And that is actually the default. So we don't really need to set this, but it's good to know that drop is there. And then we do also want to make sure that we do this in place, equal to true. Now, for those of you that are new, that don't know what in place really means, and I haven't explained it yet, all it means is that on this line of code, that we're going to update the entire data set right here. If in place equals false, then it will not update the entire data set on that line of row. And what you should do is you should go ahead and make sure you do save it to a new variable. And then from there, what you would do is you do summer.head. Now the same thing, before I run the code, the same update will occur if we have in place equals true and if we got rid of this. And then if the other thing was just like in place equals true, right? So let's go ahead and leave it, run it, and now we'd see that athlete, so it used to be right here, it's dropped, and we now see that this athlete is over the index and that there's now another layer for where the columns exist. And this will be useful when you start working with hierarchical, I can't say it, hierarchical indexes. And I would really advise that you get very familiar with that, especially in the real world, where you have things that are just correlated with each other because one line of rows will have a child ID, a parent ID. In essence, there will be relationships between these columns, and you'll need to figure out how one line of code is related to the one above it, and then this line of code is also related to like another one. And it could get very, very confusing, and it'll screw up your pipelines if you don't know how to work with the data. So just in the real world, I don't know what I'm saying. I'm just gonna move on. Just practice, and if you get frustrated, take a break and then come back. Give yourself like the Pomodoro technique. Go for a walk. So after that long tangent, let's go ahead and move on to the next flashcard. So what does the below output for the Titanic data set? So if we have mask, which is equal to 1, and then we're looking for, mask equals Titanic.sex equal to female, and we're going to see that it'll be false, true, true, false, or so on, right? It'll be false if it's male, true if it's female. So it's the opposite of what we did a little earlier where it had male instead. And if we wanted to be able to see the individuals that are younger than 14, what we would do is we'd go ahead and run this code in essence. So it would give us individuals that are younger than 14, so it'd be true for anyone younger than 14. So based on these two, now that we know that we're going to be working with females that are younger than the age of 14, if we were to go ahead and run this, what in essence would this return? So we have mask.head. So this is going to get a little confusing. So this sign right here, it means or. So whenever you're working with like the and symbol, And usually means we want females that are younger than 14, and we want both of them together. So that means we'd want females and they must be younger than 14. If we have or, I mean, this is probably really basic for most of you, but or will be we want females or younger than 14. So it could be individuals that are younger than 14 can be female or male. Otherwise, we for sure want all females. Yeah, if that makes sense. So or is one, either or, one or, and then that's, if one is, then it's true. If the other is, then it's true. But and it needs both to be true. So if we were to go ahead and run this code, titanic.locate .lock mask1 or mask2, what would it return? So since I already kind of gave the answer, what it would return in essence would be any row so long as it has either female or it's younger than the age of 14, and younger than the age of 14 can be either male or female. So well, let's go ahead and see what the answer would be. So as I said earlier, it'd go ahead and return rows that are women or anyone below the age of 14. So that symbol just means or. And then as we see with the output, we have female, 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 male, how old? 2. And then female again, 27, female, and so on. So that's useful. Something that I think I would like. I was thinking if I should kind of go back over this again in the Colab, but I'm going to go ahead and just click good. And then if we get back to it again, I'll go ahead and like finish up the video with this. So by like coding it out, I mean. So what else? So we're going to go ahead and re-import our summer data set, it looks like. And what's happening is we're going to go ahead and read it, summer.csv, index equals athlete, or index call equals athlete. So again, index call. And I'm repeating that so that way I can repeat it for myself. Now, so what will the below output? What is the following output if we use a summer data set? Now we have summer.rename eos Alfred, access equals index, inplace equals true. So this one's actually really straightforward. All that's happening is we're updating the J to a Y, and they still are pronounced as eos. Spanish speakers, feel free to correct me. I took like 3 years of Spanish 1, so I've quite a lot of practice. Yeah, let's go ahead and show the answer. So we do see that eos is updated to eos. You gotta have the J. But yeah, that was updated as well. So by the way, I love Spanish. That's why I'm kind of saying it. And I'd always scream, "Donde está la biblioteca?" Where's the library? And I would just always say it for whatever reason. Don't know why. So yeah, I feel really good with this, at least updating the index name itself. And likewise, notice how this is indexed. And if we were wanted to update the column name, what we would do is we'd still do the same things, but change this to columns with an S. And then we go ahead and pick the whatever column we wanted updated. So that's another way. So index values as well as columns. So that's good. And let's go ahead and move on. Now this actually should be good. I haven't seen this in a bit. So what does the below output for the Titanic dataset? Well, it doesn't output anything. So what does dot between or is in do? A better question would be, how could we write it? Like, let's go ahead and work with this dataset. So this is our Titanic dataset. Now let's go ahead and use dot between, and let's go ahead and figure out, I guess, how we could locate some specific rows of data. So let's go ahead and run the dataframe.head so we are able to see the Titanic dataset. Now our goal is to use dot between. And yeah, oh, between time, nice. Let's go ahead and do age dot age between. Now, by the way, I'm mostly guessing on this one. I haven't actually used between. Yeah, so I'll just leave it at that. So what I'm in essence guessing is I want to be able to pick anyone between, never mind, I guess it'll populate for us. So what will happen is the left is a scalar or a list, and then the right likewise is also a scalar or a list. Now since this one is an index, or a integer, a numeric column, I knew that I wouldn't have to actually work with strings, so I wouldn't have to say between 36 and 14. But yeah, let's go ahead and run this. And let's just see, actually, is there an inplace equals true? It says inclusive equals true. So what is inclusive then? It includes boundaries, okay? So it returns a series, okay, so that's good to know. And then here is an example. So it'll return either true or false. Interesting, okay. So let's go ahead and run it. True or false. Cool. So I think that this flashcard needs to be redone, but also how would we use is-in? Something you could do, like I'm just thinking of a conditional statement. So if data frame dot is-in 14, then do whatever, right? XYZ, or we'll just do paths. But yeah, so let's go ahead and see what the answer is, and then I'll kind of decide if I want to update this or not. So we have my favorite games, and it's a list, 1972, 1996. Notice how I'm using the summer data set here, but there's Titanic up here. Cool, so summer.year.is-in my favorite games, which is 72 and 96 .head, and we'd be able to see games in the year of 72 or 96, whereas this one would be between 1960 and 1969. So I think a better question would be it returns data between, which is a range, or is in a specific range as well. So let's go ahead and let's run it. So let's, if we wanted to, what we could do is we could do titanic.age, titanic.age.is-in, and then we could do like a list. So let's go ahead and do 14, 18, and 22 or something like that. So let's go ahead and do my age list equals like 14, 22, and 28, as I always said, or 26. Regardless. So we have this one. Now let's go ahead and do dataframe.age.is-in, and then let's go ahead and do my age list, and let's run it. Let's just see what happens. Now let's also go ahead and see what the dataframe.head is, so we can see what the actual age would be for the first couple of individuals. So we did choose 14, 22, and 28. Now we are able to see false all the way through 4. And that's true. So let's go ahead and switch this up then. Let's make this, how about 38? Let's go ahead and make this 38, rerun it. And now we see that there's a true. So, and then just to be safe, let's make this a higher value so we can, oh no, this one would also show as true. Let's go ahead and do 54 as well. So now, when it comes to is-in, it would require a specific value, such as 14, 20, or 54. So now that we know that we'd be selecting is-in would require like a specific value, whether it be 14, 22, or 54, let's go ahead and change this to between. And let's go ahead and actually let's just run it. No, let's get rid of 22 because I have a feeling I know what will happen. Let's go ahead and run it. So we still get the error. So it's missing one argument, right? Okay. So let's go ahead and do, let's just do 14 to 54. 14 to 54, right? So we'd see false, true, 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 true because they're between that value. So is-in requires a specific value to match. Between is like a range. So yeah, so what I'm thinking about doing is let's go ahead and just finish up with just doing a left join, mostly because I think I'm coming up on just about 30 or 40 minutes. So, and then joins are like just really good to work with. So let's go ahead and see what our data set is. So let's actually re-import our pandas, or let's re-import our Titanic data set. So pd.read CSV. Titanic.csv, dataframe.head, so we were able to see it. Nope, good job, Doug. Titanic, so no such repository. But I brought it in, so it must have just, oh, Titanic train data set. Okay, that's why. So now if we look at our data frame again, we said that it's been re-updated. Let's go ahead and look at the data set, and let's go ahead and like group by. How about we group by the P class? And let's go ahead and include, how about the fare? And let's do sum. Now if we were to run that, we'd have all these values here, and we'd see the sum of the P class, of the class for the fare. So let's also go ahead and say like this is data frame 1 equals this, so that way the output will be data frame 1, which would be these values. So when we do a left join, all that's happening is wherever it says 1 in our data set, it'll go ahead and join left. So let's get the first like 5. So we have 3, 3, 3, 2, and 2. So again, if we're doing a left join, what would happen is 2 would join with 2, and then on the very far right column, you'd see like a fare X or fare Y, which just means that it's like a new column. But in essence, we'd be able to see, actually these would be P class, but the point is that anyone that has 2 as a P class would have this value. Anyone that has 3 as a P class will have this value as well. And something good to remember is always try to join on a single value to either 1 or many. So always have just 1 and try to go to either many, or 1 and go to 1. Just so that way you're not creating duplicate sets of data, because it can get very, very confusing, especially when you do try to create like a dashboard or a chart for total sales, refunds, chargebacks, and if executives have their numbers all screwy, then, well, that's just bad. And then you'll have more coding to do and more of a headache. So let's do a left join. So we have our data frame. Let's go ahead and do join. Now what we're going to be joining on or with is our data frame 1. Now let's go ahead and do on will go ahead and equal the P class. And then from there we do how's left. So left is already like the default setting. So technically you wouldn't need to write it out, but I will. We want to do left, lefty, left. And then the left suffix. So the left suffix will be our data frame. And what I want it to be is I want it to be P class. And the right suffix, by the way, I'm probably going to get rid of this. So let's get rid of this, because I actually want to experiment just now, but let's go ahead and do the right suffix. So the left suffix will be this column that we're joining on. Like this data set, we're choosing the left suffix to be this data frame. So again, left here, left, yeah, you get it. And then right suffix. So right suffix. Right suffix will go ahead and equal our index. Oh, actually, yeah, no, because this is the index in essence. And let's go ahead and just run it. Let's see if we get the error. We didn't. Okay. So the reason that this writes, let's actually just make sure that populates first. So we have the fare index. Fun. Okay. So the reason that the right, which is correlated to this side, The reason that we're choosing right index is because when we group by the data, even though we're saying we want to group by the P class, generally in SQL, yes, this will be the value that you're grouping by. But because we're working with data frames, what's happening is we have our P class, which is being grouped by. And now if we wanted to actually kind of rerun this, so let's actually add one more column so we could see what I mean. So let's do survived. Run it. We now see that we have fair and survived as well. But we still want to be able to join the data on the P class, which is technically our index. So just try to, I don't know of any other way of just saying try to memorize it, but the best way is if you can just like close your eyes and visualize that you're going to take, every time there's a 1, it's going to go left because we're choosing left. Just focus on left for now. Don't worry about inner, outer, right. Just do left, and then honestly you should be good to go after that. And most interview questions will be what's the difference between a left join and an inner join. If you're lucky, you'll have some other combination of stuff and you'll actually know it. But yeah. So again, we're just joining the index, so this is the P class, and we're choosing the left suffix, which is here. The left side will be the P class that we want to join onto. So again, every time there's a 1, we'll have this value. So if we see on this far right side, we have a nan. Now why does nan populate? P class was 3. Joy, 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 joy. But whereas we have the actual value on the left hand side for 3, and likewise another one for 3 as well right here. But notice how this is increasing in value. And then there's a bunch of nans. So homework is going to be, why didn't they actually all just have the same value? So I'm going to go ahead and do that for myself, especially because I'm still used to SQL. So whenever you have 1, it'll just join left. My gut is telling me that because we're doing the sum, that is also why. And likewise, there might also be a rolling value. So what I'm going to go ahead and do is I'm going to go ahead and hop off right now. I'm going to go ahead and do some additional research to see if my hypothesis is true, if it's because of either the sum or if it's because of some other value. But notice that when there is something that screws up like this, imagine if you would have joined like many of these to many of these, meaning many different ones to many different ones. It's just, this is just kind of the headache process that you will go through. So the more you get used to the vocabulary, the more you can visualize what's going on with the data itself when you take it apart and join it back on, take it apart, join it back on, take it apart, join it back on, the better you'll get. So I kind of want to add this last little bit, mostly because I didn't want to leave you guys hanging. I did figure it out, like with regards to why the nan value was populating. The reason that it was populating is because I didn't select what we wanted to join on. I realized that the data itself, this P class, was still joining on to the index. So that's why we had a nan value for index 0. For 1, we had the actual value, and then for 2, we had a different value. So just know that oftentimes, sometimes the simplest answer is the best. I don't know, that's really cheesy, but I guess I'll just end by saying just this is the answer, and if ever you have any questions, feel free to Google them. But if you have a gut instinct, you want to test something, I mean, you may as well test it. That's the joy of being a programmer. You can screw up so many times again and again and again, and it's not like you're not like a doctor where you need to be right, like right now. It's not necessarily someone's life, but I do know that, yeah, I'll end it right here. Please feel free to book a Snugg session and link in below. Go ahead and see you guys in the next video. Thanks.